Okay, so we are back to finish Chapter 6, Section 1. So we are in 6.1b. My 6's and my b's look so much alike. I'll make that a capital B. There we go. 6.1b. We're going to finish Chapter 6, Section 1. We're talking about inverse functions, and we're going to start putting those things to work for us. When you're dealing with inverse functions, you want to be sure that you identify the range first. So I want to stop and think, which two quadrants am I looking at? Which two quadrants am I looking at? And remember, that is determined by whether I am y dominant or x dominant, right? I've got my unit circle here, and I know that things that are y dominant, focused on the y-axis, are negative here, positive here. So I am using these restrictions from negative pi half to positive pi half when I'm doing sine inverse, cosecant inverse, because that's the reciprocal of sine inverse, or tangent inverse. And I know that from 0 to pi, I have all the positive and negative values. If I do these restrictions here from 0 to pi for cosine inverse, cosine's reciprocal secant inverse, or cotangent inverse, because cotangent inverse has that x in the numerator. So those are the quadrants that I'm restricting myself to based on which of the inverse functions I'm interested in. So quadrants 4 and 1, if I'm doing those three inverse functions, and quadrants 1 and 2 if I'm doing those three inverse functions. Okay, so here we go applying all of this. Arctangent square root 3. Well, arctangent, tangent inverse is restricted along the y, so it's restricted in quadrants 4 and 1. Since I'm given a positive tangent function value, I'm in quadrant 1. And I want to know, okay, then, what is the angle theta who has a tangent function value square root 3? Because that's my tangent function value. I'm looking for theta. Go back to your unit circle. Square root 3 as a tangent function value is not going to be the 45. It's not going to be the pi fourth. It's going to be either pi 6 or pi third. And if you do a little y over x work to figure out tangent, you know that that's got to be this one. It's got to be 60 degrees, which is pi third radians. Oh, degree measured angles. So we don't have to give the radians. We can just give it in degrees. Should have read my instructions. Okay, cosecant inverse of negative square root 2. Well, cosecant is the reciprocal of sine. So once again, we're in quadrants 4 and 1. This is a negative function value, so I'm in quadrant 4, and that means I'm going to give it as an angle in degrees from negative 90 to 0. Well, cosecant is the reciprocal of sine. I'm looking for the sine function value down here, right there. That's going to be it. So that would be, remember, from negative 90 to 0, that would be my negative 45 degree angle. Theta is going to be a negative 45 degrees there. Don't forget your degree symbol to show degrees. Arctangent is 1. Tangent inverse restricted to quadrants 4 and 1 again. Positive 1, tangent's going to be a positive 1, where the sine and cosine function values are the same. So that's at the 45. If it's positive, we are restricted to quadrant 1, and that literally is the 45 degree angle. Secant inverse is 2. Well, secant is a reciprocal of cosine, so it is restricted to quadrants 1 and 2. Secant is positive here, negative there. This is a positive value. Secant is a positive 2. That means cosine would be a positive 1/2. Well, that is my 60-degree angle. All right. Use this to evaluate the inverse trig functions on your calculator. Now, this is important. Secant inverse can be evaluated as cosine inverse of 1 over x. Cosecant inverse can be evaluated as sine inverse of 1 over x. So that is how we plug it in if we just want an approximation. That's how we make use of our calculator to find these reciprocal function values. Cotangent inverse can be evaluated as tangent inverse of 1 over x as long as it's positive. But if I need cotangent and I have to use tangent and my function value is negative, I've got to rotate it around. So I have to add 180 degrees or pi to move the angle to the correct quadrant. Now, let's look at this and consider why. If I am looking at secant and cosine inverse are positive in the same quadrant, they're negative in the same quadrant. If I'm looking at cosecant and sine inverse and sine inverse are positive in the same quadrant, they're negative in the same quadrant. But if I'm looking at cotangent inverse and tangent inverse, cotangent inverse and tangent inverse are positive in the same quadrant, in quadrant 1. But if I'm given a negative cotangent inverse value, that shows up in quadrant 2. And if I have to use a negative tangent inverse function to evaluate it, I'm evaluating it down here in quadrant 4. To get it back to the correct angle in quadrant 2, I have to rotate it 180 degrees or pi radians. So I have to add pi or add 180 to take my angle that I use my calculator to find in quadrant 4 and see what is that angle going to be with that same function value that would be in quadrant 2. Okay, let's put this to use. We're going to be pulling out our calculator. We know we need our calculator because it says with a calculator. We're going to go ahead and round to 4 decimal places. My math lab always gives you rounding instructions. They don't do so well in the notes always. So we're going to find y in radians. So we're looking for our angle y. If we know that secant inverse value, that secant function value of y is -4. Well, okay, so I don't have a secant inverse button on my calculator. I do have sine and cosine inverse. Secant is the reciprocal of cosine. So what I'm going to evaluate here, I'm going to find y cosine inverse of the reciprocal of -4, which is a -1/4. So that's what I'm going to plug into my calculator. Now, radians. Because I'm using my function value buttons, I've got to pay attention whether I'm in degrees or radians. I need to be in radians, so I'm in radians. That's great. I'm going to plug in cosine inverse, so second function cosine, of the reciprocal value. So a -1/4 as my argument there. That's the angle in radians that gives me that cosine inverse value. So I round to 4 decimal places and I come out with about 1.8235. 1.823, and then this look over here, it's going to round up to a 5. Okay, next. We need to find theta in degrees. So I need to come in and I need to change back to degree mode for my calculator, in degree mode here. Our cotangent is a -25.2528. Okay, so this is the one. Arc cotangent is Cotangent inverse is negative in quadrant 2. So when I evaluate this for theta using tangent inverse, I take the reciprocal of this, so 1 over 0.2528. This is what I'm plugging into my calculator. So I've got it in degrees. I find tangent inverse, second function tangent, of, and make sure you use your negative button, negative 1 divided by 0.2528. So that's my input. Enter. I get out an angle of negative 75 degrees. Now, we're keeping that to 4 decimal places, correct? Keeping that to 4 decimal places. So that would be negative 75.8129, about negative 75.8129 degrees. Negative 75 degrees is not in quadrant 2. It's in quadrant 4. So I have to rotate it around. That's in quadrant 4. So I need to rotate 180 degrees. So I'm going to add 180 degrees there. I've got my answer, haven't rounded it yet. Add 180. The angle in quadrant 2 that has the negative cotangent inverse, that cotangent function value that I was given, is this angle, 104.1871. So I've got 104.1871 degrees. That degree symbol is vital. 104 radians is not the same thing as 104 degrees. It will be wrong if you forget to change that. Okay, back to radians. So I'm using my function buttons. I've got to have it in the right mode. We need to be in radian mode for this one. I'm finding the angle. If my cosecant function value is a negative 3, so I'm going to evaluate that as sine inverse of the reciprocal of negative 3 in radians. So sine inverse of the reciprocal of negative 3 is a negative 1/3. There we go. And then finally, go back to degrees. Evaluate arc cotangent or cotangent inverse. Make note that you need to be in quadrant 2. Negative cotangent inverse is restricted to quadrant 2. You're in quadrant 2 here. What I use for my calculator is the reciprocal of this. What does that get me? In degrees, I gotta change my mode back. I'm gonna do tangent inverse of a negative 1 divided by 0.3541. That gets me a negative 70.5-ish degrees, right? What do? That's in quadrant 4, not quadrant 2, so I've got to add 180 to rotate it back around. So there's my angle value. That was negative 70.5 plus 180 got me to a 109.4991 degrees. Make sure you have a degree symbol if it's degrees. Okay, now just another reminder, be careful when you're using your calculator. You need to evaluate the inverse cotangent of a negative quantity. You have to first change it to the inverse tangent of that reciprocal. That's going to give you an angle in quadrant 4. Inverse cotangent is not negative in quadrant 4, it's negative in quadrant 2. So we need to adjust the output by adding a half rotation, 180 degrees or pi. Okay, that's what we practiced there on B and D. Now, if you have a positive angle value there, you don't have to rotate it. You don't have to move it because it's going to be, everything is positive in quadrant 1, so you wouldn't have to make any adjustment. You just have to make that adjustment if you are doing a negative value there. Okay. All right. Now, for this next bit, excuse me, I'm moving around a little bit here, getting some stuff done that I forgot to do earlier. For this next bit, we are evaluating the expression without using a calculator. So without using a calculator, that means I'm going to be giving exact values, so I can expect that I have another way to look at it. And for this case, we're going to be using sketches of these angles. Okay, we're going to be using sketches of these angles. So let's go ahead and set that up so that we can do our sketch of our angle. Now, we want cosine of, and then inside parentheses, I've given sine inverse. So this is a function value. The answer to a sine inverse problem is an angle. So this is information about theta. And what I'm trying to find is cosine theta. So I want cosine theta, where the sine function value of theta is 2 over 3. Well, this is a positive function value. Sine inverse is positive, restricted to positive values in quadrant 1. Sine is y over r, so that is 2 over 3. And I need to figure out x. You guys know how to do this. We've got that Pythagorean theorem, x squared plus y squared equals r squared. So x is going to be the square root of r squared minus y squared. We say plus or minus, but we know because we did our sketch that we're in quadrant 1, it's going to be positive. So r squared, r squared would be 9, minus y squared would be 4, so x is square root 5. The cosine of this angle theta, x over r, is square root 5 over 3. All right, let's go again. We want to find the secant of the angle whose cotangent function value is negative 15/8. So we are looking for the secant of that angle theta, and this is my information about my angle theta. Theta has a cofunction value of negative 15/8. Well, cotangent inverse is negative where? Cotangent is restricted along with cosine. So it's negative over here in quadrant 2. So this is my angle theta. I've got a negative 15/8. Cotangent is x over y. X is the negative value, negative 15/8, because I'm in quadrant 2. And I need r. So Pythagorean theorem, r is going to be the square root of negative 15 squared plus 8 squared. 15 squared plus 8 squared, and then I take the square root of that, I get 17. R is 17. Well, what I'm looking for is secant of that angle. Secant is reciprocal of cosine, so it would be r over x. So I've got a negative 17/15 as my secant function value here. All right, let's move right along. Here we're going to be making use of some identities. So once again, you see that it's very important that you are getting familiar with your identity sheet. It's not enough to have it there. You've got to know what you're looking for. So let's set this up, make sure that we have space for everything. For my first one here, I've got sine of, and then I've got information about one angle. I've got tangent inverse, arctangent is 4/3, and I've got information about another angle, tangent cosine inverse, or arc cosine is 12/13. These are two different angles. So what I have here is a sine difference identity. I've got sine of A minus B. I need to look at angle A, and I need to look at angle B. And then I need to evaluate them using my sign difference identity. Well, when I go, because I don't have to have all these memorized, I just have to be able to recognize, oh, I know what that is. I know where to go find it. Sign difference identity is right here. So I'm going to need to know sine A, cosine B, that product, minus cosine A, sine B, that product. So I need to know both sine and cosine for angles A and B. So let's figure it out. Tangent inverse is positive in quadrant 1. So tangent is y over x. That means that's 4 and that's 3, and we need a value for r here. So if I use my Pythagorean theorem, r is the square root of 4 squared minus, or plus 4 squared plus 3 squared. 16 and 9 is square root 25. That means r is 5. For angle B, I've got arc cosine or cosine inverse, also given a positive value, so I'm in quadrant 1. Cosine is x over r, so this is 12 and 13 like that, and I'm looking for a value for y. Pythagorean theorem. I know y is going to be positive because I'm in quadrant 1. R squared minus x squared is going to give me that value for y. 169 minus 144 is square root 25, so y is 5 here. Okay, now let's put that together into our difference identity, sign difference. Sine of A, here's A, sine is 4/3. 4/5, sine is 4/5. Cosine A is 3/5. Cosine B is 12/13. Sine B is 5/13. Find those products. 5 times 13 is 65. So 4 times 12 is 48/65 minus 15/65, which gives me 33/65 as the function value I'm looking for. Okay. On to this one. So I've got sine of, and then inside this argument I have 2 times, and remember, anytime you see an inverse function, that's inverse function value. This is information about an angle. So this is telling me that I want sine of 2 theta, where this is my information about theta. So I want sine of 2 theta. Well, double angle identity. Sine of 2 theta, there's only one option there. That is 2 sine theta cosine theta. So I need to know the sine and cosine values for this angle theta that I've been given. Let's sketch it. Arc cotangent, cotangent inverse, negative. Cotangent inverse is negative in quadrant 2. So here's my angle theta. Cotangent is x over y. I've got -5 over 1. So x is -5, y is 1, and I need to figure out r. R is going to be the square root of the sum of those squares. So 25 plus 1 is square root 26. That doesn't, I can't do anything with that. That just is what it is. So square root 26. Alright, so now I've got my identity here. Sine of 2 theta is 2 sine theta cosine theta. That's what I'm working with. So I've got 2. I'm going to write it as 2 over 1 so I can multiply my fractions easier. Sine is y over r. Cosine is x over r. I'm not going to worry about rationalizing until I see if I have to, and I don't, because square root 26 times square root 26 is just 26. So my denominator is 26. My numerator, 2 times 1 times -5 is a -10, and that will reduce by a factor of 2. So I've got a -5 over 13. Excellent. Okay, let's move on to C. Once again, we take a look at it and we go, okay, what do I got going on? Well, I've got a function on the outside. In my argument, I've got an inverse value, which means that I've got information about an angle here. So what I'm looking for, essentially, is the tangent of 2 theta. Well, what do I know about tangent of 2 theta? That's a double angle tangent identity. Right here, 2 tangent theta, 1 minus tangent squared theta. 2 tangent theta over 1 minus tangent squared theta. So now I need to know the rest of the information about my angle theta. Well, arc sine or sine inverse, positive, everything is positive. All those inverse functions are positive in quadrant 1. Sine is y over r, so y over r, and I need to figure out x. Pythagorean Theorem, x is going to be positive in this case because I'm in quadrant 1. R squared minus y squared. So I get 25 minus 4 is square root 21 for my value for x. And I know that tangent theta is y over x. Okay, so all of this information I'm going to use to plug into my identity here. So 2 times tangent theta, y over x is 2 over square root 21, all over 1 minus 2 over square root 21 squared. Okay, now I got stuff going on, right? I got to figure out what exactly I'm going to do with this algebraically. So let's clean it up a little bit and see where we end up. We've got 4 over square root 21 as my numerator. I've got, when I square this, I have 1 minus 4 over 21 here. Well, to subtract from 1, to subtract a fraction from 1, I need to make a common denominator. So I'm going to rewrite this 1 as 21 over 21. So that's going to give me, we're going to leave that numerator alone, 21 minus 4 over 21. So down here, I've got 4 over square root 21 over 21 minus 4 is 17 over 21. Now I've got this big division problem. I've got a fraction over a fraction. When I'm dividing with fractions, I multiply by the reciprocal. Let's change colors so we can kind of keep track. So I'm going to multiply by the reciprocal of the denominator, 21 over 17. Well, as I notice, I haven't worried about rationalizing anything yet, but now I see that I'm to a point where nothing simplifies as it is, and I've got this radical in my denominator, so I am going to need to rationalize. So let's multiply by square root 21 over square root 21 and see what happens here. Well, my numerator becomes 4 times 21 times square root 21, and I'm not going to multiply that together yet because I see in my denominator square root 21 times square root 21 is 21 times 17. Well, anything over itself is 1. So that leaves me with 4 square roots of 21 over 17. Now, I had to rationalize here. Why didn't I automatically say 4 times 21 is 48? Well, because I'm thinking ahead to what's going to happen next and what's going to be the easiest for me. And I see that square root 21 times square root 21 is going to give me a 21 in my denominator. So I anticipate that I'm going to be able to simplify here. I probably would not have actually rewritten this step except to show you how that works out. Don't leave too many steps out. Absolutely don't. But you can make judicious use of things as well. Okay. Next one, last one on this page. Cosine of, and then I've got 2 different inverse functions. So whenever I have 2 different inverse functions given, I assume that's because I have 2 different angles. So I see that what I'm actually working with is cosine of this angle sum. So I've got cosine sum identity, which if I pull my identity sheet out, that's cosine A, cosine B minus sine A, sine B, which means I need all of my information about angle A, and about angle B. These are both positive inverse function values, which means both of my angles A and B are in quadrant 1. Tangent is y over x, so this would be square root 3 over 1, so square root 3 over 1. Sine is y over r, so this would be 1 and 3 there. I need to find the r for angle A. I need to find the x for angle B using Pythagorean Theorem. Pause the video. Work those out. Make sure you get what I got. Now I'm going to come down and I'm going to say, okay, cosine A is 1/2. Sine A is square root 3 over 2. Cosine B is 2 square root 2 over 3. Sine B is 1/3. That gives me 2 square root 2 minus square root 3 over 6. These are not like terms in my numerator. Nothing simplifies. I can leave it just like that. Alright, just a couple more examples and we will be done with 6-1. Now this is a really lengthy section. Okay, so again, practicing what it is we're looking for. We're going to write the trig expression as an algebraic expression in terms of u. So we are not solving for a numerical value so much as just rearranging things and putting them in terms of u. I've got cotangent on the outside. I've got information about an angle on the inside, so that is my angle theta that I'm interested in. Cotangent of theta is x over y. So when I look over here, here's my theta. I've got a sketch here that gives me theta. This is 1. Secant is the reciprocal of cosine. So cosine is u. The secant is u. That means cosine would be 1 over u. 1 over u. And I need to figure out what this value would be. So my value y over here is going to be u squared minus 1 squared, or square root of u squared minus 1. So that is square root of u squared minus 1. I want the cotangent of this angle theta. Cotangent is x over y, so that is cotangent theta is 1 over square root of u squared minus 1. I've got to rationalize that. Now because this is a single radical, I just treat this as rationalizing a single term. So I write that radical over itself, which gives me square root of u squared minus 1 over, and when I multiply this times itself, that radical cancels out, so I've got u squared minus 1 as my denominator. So that's the cotangent of theta. Now the second one, I'm using the same sketch, so I don't need to redraw my, oh, I may need to redraw my sketch. You know what I think I do? Because I was given new information. You know what? We're just totally gonna skip that one. We're gonna leave that one out. We're gonna focus. That's a good example right there. We're gonna focus on that. And we're gonna look down here at example 8. Finding the optimal angle of elevation in a shot put. So I don't know if any of you did track ever, but I did not. I did keep the books for the track team. And shot put, you don't want to go too straight up because then you don't get the distance that you want. You've got to find that perfect arc to get your throw to be as long as possible. That optimal angle of elevation theta from horizontal up. The optimal angle of elevation theta that you should aim for in order to throw the greatest distance depends on the velocity of the throw and the initial height of the shot. So this is the formula that it's giving us to work with. Suppose a shot putter can consistently throw the steel ball with a height of 7.5 feet at a velocity of 50 feet per second Oh, 50 feet, yeah, 50 feet per second. And what angle should he release the ball to maximize the distance? So we are solving for theta here. And we're solving for theta here by plugging in these given values. So you are going to, this is calculator math. You're finding sine inverse, velocity squared, 50 squared, over 2 times velocity squared plus 64 times the height, 7.5. And we are finding the angle theta in degrees. I'm looking to see if it tells me that there, if I just have it written down here. I have it written down here. So we're going to find it in degrees. This is a good calculator math problem to help you practice. You should get to about 42 degrees. That needs to be the angle of elevation from horizontal, 42 degrees, to get that maximum distance from the shot put.